Flebus, who works for Cegeka. By the way, Cegeka, thank you for the beautiful location here and for the catering. I think everyone will agree that we are welcomed wonderfully. Yeah, so thank you for that.
The best is yet to come.
The best is yet to come.
There's some dessert.
We found it, but we thought it was not for. Okay. So the first talk is going to be by Gilliam Flebus. So welcome,
Thanks.
Gilliam. And it's going to be about all for one build and one build for all. So with that, let's please welcome Gilliam.
Thank you. I wanted to ask to keep some room in the couch so I can give my demos there, but that's not a problem. No. I mean, no one sat there, so it's okay.
Okay.
Yeah. First technical difficulties, starting the presentation. Okay. So all for one build and one build for all. I also don't know his name, just said Jurgen, sorry. I'm Gilliam Flebus. I graduated in 2014 and then I started at Cegeka, where I accumulated most of my experience. I started as a full stack Java developer, but later on I moved gradually to more front-end and web technologies because that's where my interests lie. If I do anything noteworthy, it's probably on my GitHub or on my GitLab. I'll also share a link to this repository, which has a link to the slides and also all of the code samples that you can review for the demos I will be giving during the presentation. So this talk will be about a bad practice that I've seen on almost every Angular project that I worked on. I hope I'm going to tell something new, because otherwise you're just doing very well. But let's hope some people also do this and also saw this and realize that it can be better. So we started a new project, a new greenfield project, and nowadays we use the Angular CLI to do that. We start by generating our new project, in this case for my demos Angular Belgium 2018. And we get almost all of the boilerplate code from the Angular CLI, which is very nice. We get the app folder, which has all of the logic, the assets, which has all of the static assets. And then we get this environments folder, which has by default has an environment for local development and an environment.prod.ts for the production build that we're going to make. Okay, cool. But I have multiple environments. I also have tests and acceptance. So I make multiple environment files because it seems like that's what they're for. So this is what I end up with in my project. I have the environment for local development and then test, production, and acceptance environment as well. If I want to build my project or test my project, or I want to run it, then I can just pass the configuration parameter to tell which environment file I want to use, and my environment will be injected. Let's see what this looks like in an actual project. I mean, it's something you probably all seen before. Inside of the repository, you'll find a project workspace with 5 projects, the environments, and then the ones yet to come. And inside this environments application, you'll find the example I just showed with acceptance, production, test. So what do we do in the environment? We have our backend URL, which in the local development case is localhost. And in the other cases, it will point to, for example, our test server, production and acceptance server for the other files. So when we run it, am I the only one that didn't mute his phone? Oops. So this is the test project. It's very simple, always to just show the example. Here we see that the backend URL that our project gets is localhost. Inside of the code, you'll see if you go to the app. Can everyone hear me when I'm talking that way, by the way? Okay. So in the project, we can see inside of the app component that it's hard to work with lag. Okay, that this backend URL variable that we use in the app component is coming from environment.backend URL. So if I start it again, but this time I passed configuration parameter succes, for example. Then we can see that our backend URL did not change, which is strange.
Good catch.
Thanks.
Now let's hope it changes.
Uglifying. Okay. Now we can see that the backend URL changes to acceptance. So with this, we can point our front end or client to whichever backend we want by changing the environment file. Oh, I used the wrong shortcut. Now I know why it didn't work. Okay. Oh. So that's nice. We have a project which has environments for test, acceptance, production, and local development. But it's actually not so nice. Why is this not nice? I hope a lot of you have seen this kind of setup or build. Maybe raise some hands. Who has seen the way of working like this? Okay, for different environments. Okay, perfect. And I'm not telling you something you already know. Perfect. Who knows why it's not great to do it like this?
Because you have to rebuild your project every time you promote your project to the next stage of the development phase.
Yeah, indeed, very good. So this isn't nice indeed, because to see what the problem is, we're going to describe what we actually would want, what the ideal situation is. And that's actually that we have one package for every environment. So in this case, you see you have three yellow boxes, which is our build application. For the three environments, they're all yellow because they're all exactly the same. And what we want is that our environments inject our environment variables into the package. So this way we can indeed have one build for all environments. But if we use the environments from Angular like this, like I just showed, then what we're actually doing is putting the environment inside of the application and creating three separate builds for, in this case, for three environments, but creating different builds for each environment. So if you're still wondering, then I'll show you, other than that point, why that's not a great idea. Also, the title here is backend devs know, because like in backend development, this isn't such a big problem. It's logical to make one build and inject environment variables. And I'll show why in front end it can be a problem. One thing is build times. Indeed, for every next stage you would have to build again, but not only build again, but lint your code again, test your code again, actually also run your end-to-end tests again if you want to do it properly. It takes a lot more time. It will multiply with a new factor for every environment you have. So that's not very nice. Your application is also not portable. You couldn't port it to a new environment without rebuilding it once again with the new environment variables also baked in. And it's also just a bad idea, because you want to be sure that the package that you have when you promote it to the next stage is exactly the same. If you have a little bit of time between your builds, between test and acceptance, for example, everything can change, the whole world can change. someone could delete a dependency on npm, which makes all the libraries invalid all of a sudden. Package lock is like the file that locks your dependencies to a specific version, which is mitigating this problem a little bit. But I mean, even the build server that gets an update or something, you can never be sure that your packages are the same if you have some time between them. And there was another point that I'm trying to think of because I put it in the speaker's notes and not in the slides. All right. You cannot live update your environment. What you would want is that you can change your environment if you want. So if you want to change the backend URL for acceptance, then you want to change the config file. You don't want to redeploy your application. Maybe restart it, but redeploy would be pretty insane. So then why do we have this situation in front-end development? I'll wait until the phone is done ringing.
The exits.
So how did this evolve? Why did we do this? Why, if we already knew this from backend development that it's a bad practice, then why did we start doing it in front-end development? Because the way that backend and front-end work are very different, obviously. The major difference being that if you have a backend application, it gets deployed to a certain server. I took the ID card symbol because it looked most like server and I didn't want to search other icons. But this is the server for the rest of the presentation. It gets deployed to a server. And for example, if you have test, you inject the test environment variables and the application picks those up. For acceptance, just the same other environment variables, and for production again. But with front-end, you also have your front-end server. Your front-end server could have environment variables for who knows what. And you deploy your front-end to the server, but your front-end does not get executed on the server. If we do not think about server-side rendering for now, your front-end gets downloaded to a browser, and in the browser you don't have the environment variables anymore. Well, that kind of sucks because that's why we do what we just saw. So what we ideally would want is to get the environment variables also to the browser, but not in the package, but separately, or something like that. But actually, maybe we don't need to do that. We actually don't need to know all of the environment variables. We need to know one thing, and that is where is our backend? What API are we talking to? And then all of the other variables or all of the other aspects, varying aspects, can come from the backend itself. So we just need to know what to talk to, basically. So I'm going to talk about and show you 3 different solutions to this problem. You can choose and also talk about the disadvantages. And the option that you choose will probably depend on how much control you have over your environment, as you will see. So the first solution will be to have a configuration file that gets loaded dynamically on each server, then to deploy both the backend and the frontend to one server, and to use a reverse proxy. So we'll start with the config file. This solution would be that we start with the same concept. We have our frontend server with our package deployed to it. But now we also have this small config.json, or well, you could call it whatever you want, of course. In my case, config.json file, which has very simply, it's just a JSON object with one parameter, namely a backend URL, which has the URL to our backend. So what happens this time is, again, the application gets loaded in the browser, but now before the application does anything else, it's going to fetch the config.json file from the same server. In this config.json file, it sees like, oh, this is where my backend is, and the rest of the calls all go to the backend server. Let's see it in action. So the JSON config example is the one we just saw. To set this up, we need to change a little bit in the angular.json. We have, by default, you have this production environment at the top, configurations production, which tells the Angular CLI which files to replace. So with production, it's to change the environment file with production.ts. You need to make. Wait a second. That's not true. I'm talking about the environments. The environments example. My bad. So JSON config. What we're going to see is in assets. It's in assets right now, but when you would deploy the application, it wouldn't be in assets. It would be on the server right next to the application itself. So you can deploy it separately. During development, it's coming from assets because that's the easiest way I found to set it up. It's just a very simple file with backend URL, in this case, localhost 3000. Inside of the app component, we're going to see that this time we will fetch the backend URL from this app config file with get config backend URL. So getting the backend URL variable. And if we look at what this app config does, is it has the HTTP client to fetch the config file and this load method, which is going to see if we're in production or not. If we're not in production, working locally, it's going to fetch it from assets. But if we're in production, it's just going to fetch config.json. So from the same server, it's going to try to fetch this config file. Now you could maybe some people think like this is asynchronous, then you'd have to wait or check in every new class. Is the config file already loaded? And that's not something you want to do. But apparently Angular now has this concept of an app initializer. I didn't actually know before making this example. We did it in a pretty dirty way because we couldn't use the Angular framework because it hasn't initialized yet. We loaded the config file with XML HTTP requests, the pure JavaScript call. But now you can use the HTTP client with this app initializer. You can provide a server service, this app config in this instance, and call a load method. I do think it has to return a promise, but this will get executed before the rest of the application initializes. So you can, in your app component, as you see, you don't have to check if it's already there. It's just, it will be loaded beforehand. So if we start this, we now have the JSON config application, and this has also the backend URL, localhost 3000. Unfortunately, I can't show you the full power of doing this separately. If I change this to something else, it will rebuild the application. If you would have deployed it on a server, you would not have to rebuild the application. It would pick up the new config file, and now you can see that localhost is now our local development server. So that's it for the JSON configuration. This is still clear to everybody? All right. Some disadvantages of this approach. Small disadvantages is that the environment variables are coming from a config file, not from actual environment variables. So you need some extra string replacement setup or something in your deploy process to also put it in the file. But that's not a big disadvantage. The biggest disadvantage is that your app cannot do anything else while loading. It first has to fetch the JSON file before it boots. So it will take a little bit of extra time, one HTTP call for a small file before it can actually boot. Then we have the option of using only one server to deploy our application. So if we do this, then we have this server once again, but because we use the API and the front end because we deploy it to the same server, we actually don't need to have any configuration to know where our backend is, because it's just on our own server. So whenever the application gets loaded, if it needs to know something, it just calls the same server. And this is really easy to work with, because you just have to make calls to slash. Don't have to prefix your calls with some configuration. So let's see this example. So this is the one server example, and you see that there's a one server application, but also a one server API application. If you want to run it, well, if you see the repository, there are readmes in every project, so you can get the steps to run everything. One server is also just a very simple application, also just one app component that does a call, a HTTP call to /log whenever the app gets initialized. It's of course just for simplicity, don't make HTTP calls in your components. But if you want to run this example, we're going to go to the one server API, which is a simple Express application that just has this. So we have the get log, and whenever get log gets called, it's going to print to the console server connection works in light blue. It's going to return a connection object with connection true. And then we have this line, the use express static. And that actually means also serve static files on the root from everything that is under /app. So in the build that you make for this application, you also have app. This has the front-end application, and the rest of the files are the server. So let's run this. We cannot, because the application package is also the front-end server in the same API. For this example, we have to go to the project itself. So the one server API. This process will start the backend and the frontend. So as we see, yeah, it also starts the Angular build. They do that every coffee machine. Oh. So now on localhost 3000, where the backend is housed, we can see that we can also get the frontend. So the one server example. We don't need to know where our backend is. We just call /, and that's what the application does. As you remember, the /log that it was going to call. So now we can also see in the backend that the server connection works, because when we just started the application, it also made the call to the backend. And as you can see in the front end, whenever I succeed to get the terminal down, you don't need to know where the backend is. You just make your calls to / whatever your API looks like. Some disadvantages of this, maybe you already thought about it. Your frontend and your backend run on the same server has to have some disadvantages. It's not possible to scale the backend by itself. You always run them on the same server. It's not a very good separation of concerns, because one server will take care of running the API, but also running the frontend. So it could also put your backend server under a bit more load, because sometimes it also has to serve the files for the frontend. But I think the biggest disadvantage is that you can't scale your backend without scaling the front end, or without duplicating the front end server. And then the last example I have is to use a reverse proxy. It has the most stars because in my case it's the cleanest option. You may disagree, of course. Talk to me afterwards. So when we use a reverse proxy, it's the same for the front end. It will be the same like in the one server example. So we have our front end running on our front end server. And now you can see that our front end server has this backend URL environment variable, or in some way it knows where the backend is. Your front end gets served again to the browser. It makes a HTTP call, and your front end server knows where the backend is, as it's saying. So it's going to proxy all of the calls that go to a certain endpoint to where the actual backend is located. Because it's the front end server, your environment variable can change, and your front-end server can proxy to another backend. You could switch at runtime. It's not coupled to the application itself. So yeah, little example of this. I hope I don't screw this up, because this uses Docker, because that was the easiest way to set it up. So the reverse proxy project, it has start with the Docker file. So I'm going to use the API, the API server that I also used for the one server API. So that one has a Docker file as well. Are there a lot of people who don't know what Docker is? Maybe raise hands. Who doesn't know what Docker is? Oh, yeah, who doesn't? Okay, that's okay. So you can see it as a very lightweight virtual machine. So it's a container that runs your application, kind of acts like a whole operating system. So it packages not only your application, but also the dependencies and the platform within it. So with Docker, it's easy to set up a server that's completely self-contained without having to mess up my operating system. For the backend, this Docker file is just starting from Node, so it's a Node application. It's the Express application we just saw. Copies Node modules and main, and just runs the server that we just saw, the one API, one server API, with the /log. And then for the front end, the reverse proxy, the front end will run on an Nginx server, which is also just a small server, but it's very easy to set up a reverse proxy on Nginx. So this Nginx will copy the front end application and serve that. But we also see that here we have this Nginx configuration that we copy to the Nginx default configuration. So that is this file, Nginx custom conf, and this is where the magic happens. This is where you have this location /API block, and you see it also reads very simple. It's proxy path, so everything that goes to /API will be proxied to server 3000. The fact that this is not localhost but server is because I'm going to use Docker Compose to make these two Docker containers communicate with each other, and then you can just use the name of the other Docker container as a host name, which is insanely cool, but might be a bit vague here. So this will be to the one server API. To set up this, I did the building at home, so normally I can just call Docker Compose up, which will start the front-end server and the backend server. So we have this log statement from the backend. And now if I go to the front end, if we go to the terminal, I mean the file, let's see. We can see that this reverse proxy application will also do exactly the same as with the one server, just call its own server, this time prefixed with API, because all of the API calls gets redirected to the one server API. It runs on port 8080, well, which is in Docker Compose, but you can believe me. So port 8080 is the reverse proxy application. It calls /API. And if we go to look at the console here and search between the front-end application logs, we can see this server application log server connection works because it also makes this log call to the backend. If we refresh it and go to the network tab here, we can also see that log API gets the connection through from the backend. Those were the examples. I'll leave a little bit of time for questions in a second. So this also has a disadvantage because nothing is perfect. You have an extra HTTP call if you do this because the front end has to proxy all of the HTTP calls to the backend. So there might be a very slight performance loss. In my eyes, however, this reverse proxy is most of the time, if you have full control over your setup, is the cleanest solution to make your front-end application not know where your backend is and just do all the calls the easy way. Yeah, that's it. So we saw the config file, one server, reverse proxy. And then maybe some of you thought about why are the environment files there if I'm telling you not to use them. Well, of course, they have their use. Actually, by default, they're set up perfectly because you also want your difference between when you're developing locally and when you're running a production build. There's a lot of difference when you're running ngserve or ngserve with the production flag, source maps that get generated or don't get generated. Maybe the minification works a little bit differently. You have change detection that works a lot harder when you're working locally to detect bugs. So of course, you want to keep these differences. You still want to know when you run a production build or a local build, but your production build should be the test for all your environments should be the same. So don't see the production environment file as the one for your production environment, if that makes sense. That's it. Are there any questions? Yep.
So your example is most focusing on like switching APIs in between your development or test environment, but then it really can be used for like saying I want to have feature flags or a debug mode enabled or disabled, and say okay, this feature must be enabled on my test environment because testers have to do something with it. Whereas in production, those flags maybe have to be disabled.
I think
that approach doesn't then really.
Yeah, maybe the debug flag could also come from the backend, from the API as a configuration service that you call. But it's a good question. I must admit that I don't have a lot of experience with using feature flags in frontend. So I hope that there's a way around that. But yeah, maybe we can talk about that afterwards.
But it's something we have done.
Yeah.
It's kind of similar, but we have to do like much more than only.
Yeah,
out the backend.
that's interesting. Yeah. Okay. Yeah, we'll talk afterwards, or if someone else has a comment to that or a solution to that.
Yeah, and it's okay if you manage the backend yourself, but if you like use Firebase, then the solution cannot be really used.
Because it's dynamic, you mean? Because the backend location changes, or?
No. Okay, yes. Now I see what you will do. But then I see still another problem, like scaling. If you like have 10,000 clients, if you have a popular app, you need to connect.
Yeah.
Then everything is going via your front end.
The reverse proxy of the front end. Yeah, that's true. If that's normally that's very performance, but of course that also has its limits. I think if you would want to, if the front end server hits its limits, then you would put a load balancer in front of the front end servers and also deploy multiple front end servers that all have their reverse proxies. I mean, off the top of my head, seems like the solution to that.
then you're basically creating some kind of extra problems just to solve this configuration issue.
I'm not sure if.
I don't think so, actually.
No?
No, I'm using load balancers all the time at my client, and we just scale up whenever we need to.
Yeah,
There aren't any extra issues related to that, actually.
No, but it's an extra problem you need to solve just for this configuration problem.
That you'll always have with a high amount of users, I think.
I think it doesn't weigh up to the to building again for every environment, and well, all the disadvantages that you have if you have to make it a part of your front end. We can also talk about it some more if you want. Other questions, notes? Okay, thank you very much.
Thank you.